Hi, so hopefully you caught the last video on finding the area of triangles, because if you watched that one and saw how we developed the formula for the area of a triangle, we're going to do a similar type of thing today, but today we're going to look at trapezoids. So trapezoids are another type of quadrilateral, but they are kind of a totally different subset than what we would normally think of with like rectangles, squares, parallelograms. And the fact that a trapezoid is unique in the fact that it only has one set of parallel sides. So for example, here, these two sides are parallel, but on a trapezoid, the other two sides are not. Whereas with rectangles, rhombuses, kites, anything like that, all the other sides are always, opposite sides are parallel, but trapezoids are not. We're going to start with the Y. Now, with a trapezoid, we could start to break it into its smaller pieces. So you might be looking at this trapezoid here and saying, oh, hey, we could break this into a couple triangles and a square. And you definitely could do that. You could find the area of a trapezoid by breaking it into some of those smaller parts. But if you remember what we did with our triangle, I want you to also see the Y for where the formula comes from. To do that, I'm going to start just like we did with the triangle, and I'm going to take my trapezoid and I'm going to think about copying it. So in my head, I have this picture and it's a copy. And I'm going to flip it over like I did with the triangle, and I'm going to make it so it's connected with my current shape. And if you're like, I don't understand what you're saying, basically what it's going to look like is I'm going to take this shape, okay, oops, take this shape, kind of cut it, and rotate it around, make it a little bit bigger. Now, I know this isn't perfect because I kind of covered the other part. But when you think about like this line was here, this line was here, and what we've done now is by doing that, I've now created this huge parallelogram, except for our base hasn't remained the same because it's not just this 7 centimeters or it's not just this 4 centimeters. This 4 centimeters actually comes down and becomes part of the base down here. The height, however, stays the same. So looking at this, the area for a parallel or for a trapezoid becomes the area of this larger parallelogram. Meaning we're going to take the height of the trapezoid times the base of what would be our parallelogram. So the base of what would be our larger parallelogram was this first base, which was 7 centimeters. So we're going to call that base number 1. And then how that 4 got brought around, this is going to be base number 2. And we have to add those together because they become the full base of that larger parallelogram. But we're not quite done, because like a triangle, a trapezoid is half of a parallelogram. Because remember, we took that original trapezoid and copied it. But this time we have to use both bases. Meaning I'm going to take this area like we did with the triangle, and I'm going to divide it by 2. Or, kind of like with the triangle, another way we could look at it is it becomes 1/2 the height times base 1 plus base 2. Let's look at what this looks like. Going back to our original trapezoid, looking here, we have this long base, which becomes 7 plus 4, or 11 centimeters long. That's the full base. The height of our parallelogram stayed 3. So we're going to multiply that by 3, and we get 33 centimeters squared. But this part of that parallelogram doesn't actually exist, so we need to take that area and divide it into 2 parts. So 33 divided by 2 is going to be 16.5. So the area of our trapezoid here ends up being 16.5 or 16.5 centimeters squared. What I would encourage you to do is pause the video, and I want you to try this trapezoid down here. Now notice I did put in some extra numbers as distractors, so I want you to really think about which numbers do we need to use and which ones are we not going to use. If it helps you, you can also show how this trapezoid is still half of a parallelogram. So stop the video, try it out, and then come back and we'll go through it and we'll check your work. All right, looking at this, kind of like we did before, we can take this trapezoid, maybe not as neatly as the other one. We extend it out, bring this down. So the 6 here really comes down here, making our new base a total of 14 units because we didn't put a label on this one. Our height is still 4. So we're going to add our bases together, which we just did. So 8 plus 16, or 8 plus 16, 8 plus 6 is 14. We're going to take 14 times 4, which is 56. But because this isn't actually part of our trapezoid that we're trying to find the area of, I'm going to take that 56 and divide it by 2, which gives us 28 units squared for our area. Now this would actually be a really nice one that shows why sometimes we use that 1/2. As I was looking at this with the 14 times 4, I didn't necessarily know what 14 times 4 was. I could figure it out. I can use a calculator, but we could have also thought about at this step kind of segueing over and almost thinking of it as like 1/2 times 14 times 4, because then what I could do is I can either take 1/2 of 14 or 1/2 of 4. And if I did 1/2 of 14, that would be 7 times 4, which is still going to give us 28. But this way is a lot easier for me to do mental math, which then makes the problem a little bit quicker. So just things to think about as you are finding the area of trapezoids.